on life cycle maintenance.
So, good morning, everybody. So, in the program, the title of my talk today is life cycle management. But maintenance is a part of life cycle management and a very important part of the life cycle management. That's why, so please let me focus on the maintenance issues. So, this is also showed many times in my presentation, and the circular economy was stressed by a new action plan for the circular economy. This is a very famous paper saying that the importance of the circular economy, and in this document there is a description. The value of product, material, and resources is maintained in the economy for as long as possible, and the generation of waste minimized. So this says that maintenance is a very important part of the circular economy. So there are many kinds of the artifacts or the things to maintain, and maintenance is aimed at making best use of artifacts through their life cycle. So how we can extract the capability of the products or the facilities regardless of the area. So infrastructure, industrial machines, or home appliance, and so on. So first, I want to talk about the framework for life cycle maintenance. So there's a two kinds of the lives of the artifact, and the artifact is required to have a good functional level larger than the required functional level. So realized functional level should be higher than the required functional level. And there is a two cases that realized functional level goes under the required level. So one reason is that the deterioration of the product or the facility, and the other case is that of course although the realized function deteriorate, but at the same time, so or the before going down, the required function goes up. So in this case, we say that life is physical life, and in this case, function life or value life. So what is the maintenance activities? Usually, if the system start to use, there could be different kind of the malfunction or the failures or the not good things, and you need to improve to the level of the usable stages. And then while you use or operate the product of facilities, it could deteriorate. The function level will deteriorate. But before it goes below the required level, if you make some kind of the treatment, and that is called preventive maintenance, or the PM. And on the other hand, if the treatment is when the function level goes below the required level, which means failure, then we call that kind of the maintenance, breakdown maintenance. And also there is a case that required level increases, goes up, and for responding this type of change, you need improvement or upgrade. All these all these activity to respond to these kind of the event are called maintenance. But why we need maintenance? There are several kinds of the reasons. One is the expected deterioration. So from the design of the product or facility, this component may deteriorate due to the operation or due to the usage. Think about the tire of the car. So if you drive certain amount of the distance, then tire wears and you have to replace it. So this is not a bad thing. This kind of the deterioration is already predicted in the stage of the design of the car. So of course you may make a very long life tires, but if you're going to make this kind of tire may become very heavy or very expensive, and this is not the economic solution. And another thing is so-called forced deterioration. Sometimes, so if you drive your car very quick start and very sudden braking, then tire deteriorate or the wears very fast. So if you use your car appropriately, you can use, for example, so your tire 2 years or 3 years. But if you drive very not appropriately, so then the tire, you have to change the tire just 1 year and so on. So that kind of the problem is called forced deterioration, incorrect operation, incorrect operating environment. And also there could be some defect in design or in production. So that must be repaired or treated during the operation time. So this can happen many times, especially in the case of the infrastructure or the industrial equipment that is not the mass production goods. And also, of course, you need to sometimes improvement because of the change in the requirement. So required functional level goes up, or in the case of manufacturing, so the product will be changed, and that causes the certain kind of the impact to the machines. So then you need to improve your machines, or improve the strength of the machine, improve the speed of the machine, and so on. But if you you have to manage the life cycle of just one thing, it is not so complicated. The problem is not so much complicated, because, for example, so you have a knife for the cooking, and the knife will deteriorate due to the usage. But the knife is quite, how can I say, you have to manage just one life of the knife. But in many cases, in the products, there are so many kinds of the components, and each component usually has different lifespans, or the different characteristics of the life. And you have to manage every component to keep the products or the system working. So that makes the maintenance issues quite complicated, because one car has several 10,000 parts, and every part could deteriorate over time. So how you can manage this kind of the problem? The basic principle is you should be proactive. So that means that you need to predict the deterioration or the failure in advance. So if you don't know what will happen, you cannot consider the countermeasures. So first, think about what will happen, then prepare the countermeasures for that. So, however, the prediction could be wrong. You cannot say that your prediction is always precise. So in that case, you need to improve your prediction, or revise your prediction and improve the maintenance actions. So in this way, so you need to have this kind of the circle, management circles, improving circles. So, and this chart shows this kind of the managing loop. First loop is a maintenance task execution management loop. First, you need to plan the maintenance task and then execute the inspection, monitoring, diagnosis, and treatment. And you need to evaluate these kind of the result of the treatment, and maybe the condition of the product or facility is what you expected. So in that case, maybe you can improve the way of the maintenance or the way of the inspection, but you can continue to execute this kind of the route. But sometimes what you expected is quite different from the actual condition change. So in that case, you need to revise your way of the maintenance, that is maintenance strategy. So you need to go back to the maintenance strategy planning phase, and again predict or consider the deterioration and failures, and then what is the effective way to maintain or to inspect this kind of the failures or deterioration. So this is the second maintenance strategy planning group. And also, as I told you that sometimes design is not appropriate, or there is a defect in manufacturing. And in that case, you need to improve the product or the facility itself. So this is the third group, product or facility improvement group. So this kind of the PDCA loop should be implemented in your maintenance system. So then you can respond to the changes of the, for example, the operational condition or the requirement, and also you can improve your maintenance tasks or the activities during the life cycle. So the important thing is that you need some mechanism or the system to manage this kind of the group. So in this chart, so the most important point is maintenance strategy planning. And next, I want to speak about the maintenance strategy planning. So first, we have a categorization of the maintenance strategy. And usual categorization is that a maintenance strategy is divided into preventive maintenance and breakdown maintenance. And preventive maintenance is divided into time-based maintenance and condition-based maintenance. So time-based maintenance means that when you operate 1 year the machine, for example, then you may replace some parts. So this kind of the maintenance is a time-based maintenance. Of course, you can measure the amount of the it can not be based on the clock time, but the total driving distance. It reaches the 10,000 kilometers, then you need to replace something, replace the oil and so on. So that kind of the maintenance. And the condition-based maintenance is you apply the treatment such as replacement or the repair based on the conditions which is inspected or monitored by some means. But sometimes there is some kind of confusion. When you make an inspection periodically, like every 6 months, so in that case, sometimes people says that this is a kind of the time-based maintenance. But time-based maintenance is not a periodical inspection. It does not mean periodical inspection. Periodical treatment or the replacement or the repair. So therefore, I am proposing the categorization of maintenance strategy in 3 axes. One is the criteria for applying treatment, and another is occasion or interval, and the third is method of treatment. So, criteria for applying treatment means that one is time-based, one is condition-based. So, time-based is, as I already told, that apply treatment at a certain interval without checking the machine condition or regardless of the machine condition. That is the time-based. If you know the life of the component exactly, then it is an efficient way. The condition-based maintenance is applying treatment based on the condition of the product or facilities. And in definition, breakdown maintenance is also included in the condition-based maintenance. But sometimes or the many times breakdown maintenance is defined or treated as a separate maintenance strategy. But in definition, breakdown means applying treatment after failure condition. And another way is the symptom monitoring or the symptom detection. Apply treatment when a symptom is detected. And if you have a good knowledge about the deterioration, you can predict the trend of the deterioration. So when it will go down less than the threshold. So then in that case, you can decide timing of treatment based on the prediction of deterioration progress. So another axis or another item of the categorization is occasion and interval. Occasion means during operation, when machine stops, when the machine is disassembled. So whether it is treatment or the inspection, sometimes you can inspect the machine condition during operation, such as the vibration monitoring. But sometimes you need to stop the machine to check the oil and so on. And sometimes you need to disassemble the machine to check the, let's say, wear condition of the bearing and so on. Interval means when the time-based for the time-based maintenance, interval of treatment, and condition-based maintenance, interval of inspection or the monitoring. Method of treatment. There are many kinds of the way of the treatment, but they are categorized into three: recovery of deterioration, adjustment, repair, replacement, mitigation of stress, cleaning and oiling, improve operating conditions, or the reduce the stress, to choose the operating condition to reduce the stress. Elimination of cause of deterioration, changing the material, changing the structure, and so on. So how we can make a maintenance strategy? You need to think about the two factors. One is the technological factors, or you need a technological evaluation, which means that how the machine will deteriorate, how the machine fails. So there is a stress from outside or from internal, and then this kind of stress causes the deterioration of the parts of the component, and that lead to the unit failures or the unit functional deterioration, and then system failure or system functional deterioration. So there is a certain kind of mechanism of this phenomena. You need to know. And also what is important is you need to evaluate the impact of this failure or deterioration. So if, for example, if the one of this light fails, it does not affect the continuation of my lecture. But if this projector fails, so I cannot continue my lecture. So the impact to my lecture is quite different depending on the role of the component or the role of the machines. So therefore, in making the maintenance strategy, we need technological evaluation for selecting technologically feasible strategies. And at the same time, you need a managerial evaluation that is prioritizing the maintenance object. What is more effective, and so on. And then you can select the criteria and kind of the treatment and timing and cycles. For technological evaluation, you need to know the structure and functions of the machines. What type of the, or what kind of the structure does it have, or what kind of the function they have. And also, from each, you need to look at each component and how they deteriorate, how they fail. And if you know the good knowledge about the failure, you can model the deterioration of the failure phenomena in terms of the physical model or the statistical model, depending on how much knowledge you have about the failure or the deterioration. And what we want to know is a progress pattern of the deterioration and failure state. So the state is divided into 3 stages: a normal state, nothing wrong. And symptomatic state, that is, there is some symptom of deterioration or failure, but still usable. The machine is usable. But if the functional level go below the functional limit, then fault state means that you cannot continue to use anymore. So the question is whether you can predict this timing or this timing, start of the symptomatic state or the start of the fault state. Or also you need to know how long this state. If the failure occurs quite suddenly, you cannot, the prediction of the detection of the symptom does not make sense because you don't have enough time to react or to prevent the failure. So in this way, if the failure occurs quite suddenly, then condition-based maintenance cannot apply. But if the deterioration progresses gradually, then you can have a chance to get the symptom of the failure. Also, if you know when it fails, then the failure is predictable. You can apply time-based maintenance. But if you don't know when it fails, so that can fail now or 1 year later. So in that case, time-based maintenance doesn't make sense. So in this way, you need to know the characteristics of the deterioration or the failures to decide what type of the maintenance strategy can be applied to this kind of the component. And for managerial evaluation, you need to evaluate the effect. Effect can be, there are different kind of the effect. For example, so in the case of the manufacturing facilities, the quality aspect, cost aspect, time aspect, and the effect to the human, machine, material, environment. So you need to enumerate every category of the effect. Then evaluate the stress, the amount of the stress of these effects. And then maybe some effect can be measured by the money, cost, but some effect can be, for example, injury. That cannot be directly assessed by the money. So in that case, you need to weight of each effect to integrate them to one measure, the impact or the effect to evaluate the effect of this failure and so on. So the effect should be estimated for each failure. So these are the very basic items to be considered in maintenance strategy planning. And in many cases, the people said that the characteristics of maintenance differ from one industry to another. If you, of course, there is a field of the maintenance, but sometimes maintenance is discussed in the construction, the architecture area, or the mechanical area, or the airplanes, aeronautic area, and so on. So each industrial or the product area within this kind of the field or the area, maintenance is discussed. And sometimes they are not communicate with each other. So that is a big problem of the maintenance management. But if you know what is different, what is, if you can review the reasons for difference, then you can know what is the commonalities. What is a common issue in the maintenance, even though the area is different. So so that's why I'm trying to categorize the approaches of the focusing point of the maintenance. So first, I categorize the effect of the failures. It is divided into, or the categorized into facility-related effect. That means the cost of preventive maintenance or breakdown maintenance. And another one is value creation effect. Value creation effect means that when the manufacturing machine stops, you cannot produce the product, and then you have some loss. So because you cannot produce the product and sell the product, so you have a loss. In this case, the loss is categorized the value creation effect. And also another one is the effect of induced damage. Some failure of the plant will cause the fire or explosion that breaks the adjacent machines or the injures the humans. Another point is the cost types. When you apply the maintenance, so how much the cost you need? Ideally, if the treatment is replacement, then the cost of the item does not change, even regardless of when you change the component. But if the treatment is a kind of the refill type, then the cost increases in proportion to the deterioration, level of deterioration. And there's another type, repair type. For example, concrete structure. If you let them deteriorate in a very bad condition, into the very bad condition, then you need a lot of money to repair it. But if you apply the treatment appropriate timing, then you don't need so much money for that. And another point is you need to think about the overhead cost. That is very important because if you have a furnace for heating some material, so in that case, if you want to maintain the inside the furnace, you need to shut down, but it has a high temperature and you need to wait for cooling down the inside the furnace. And after repair, you have to start up and it takes time to go into the certain level of the temperature. So during that time, you have to stop your production activity. So that makes a big loss. So in these two items, I can identify these four types of the approaches. One is operation and maintenance. Operation and maintenance interaction become a major issue in maintenance management if dominant effect category is value creation and overhead cost is big. So if you put the stress on the operation, then you cannot apply the appropriate maintenance. That causes the deterioration of the facility, and then that causes the quality of the material, quality of the product, or the yield of the production. So you need to compromise the maintenance and operation. That is so-called operation and maintenance integration problem. Another type is life cycle costing. Optimization of life cycle cost becomes a major issue in this maintenance management. If the dominant effect category is facility related and the treatment cost category is repair type. So timely application of the treatment based on proper identification of the facility condition is very important in this case. So you need to think about the life cycle cost. So, for example, this is a result of the simulation of the concrete structures. So if you don't put the appropriate effort or put enough money to repair the defect at the early stage of the life cycle, then the cost will increase gradually. But if you put enough money to eliminate the problem, then you can have a stable cost profile during the life cycle. So this is quite important. So just let as the deteriorate, then that makes a big loss. And another one is risk management. So if the dominant effect category is that from induce damage, and a single failure, or not necessarily be a single, but anyhow, even in a single failure induces enormous effect, such as explosion and fire, and so on. So in that case, you need to assess the risk, the amount of the effect multiplied by the sorry, the chance of the occurrence chance of the phenomena. So in this case, you need to take preventive action to reduce the risk by improving the facility for improvement of the facility or control the risk below the acceptable level. So this kind of approach is called risk-based maintenance. So the method is quite established, especially in the area of the chemical or the oil plant. Or first, it was applied to the nuclear plant, and then this is the application area expand to the plant. And the final category is a kaizen or improvement. So if the dominant effect category is value creation, there are many different types of machines, and the overhead cost is not significant. This type is can be found like automobile factory. So there are so many kinds of the machines and so many kinds of the fault failures. So you need to when it occurs or when it is predicted, then you have to apply to prevent the reoccurrence of the failures. So in the assembly line of the car manufacturers, if you find anything wrong, then stop the line and apply the treatment and then restart it. So this is quite important. So rather than making the defective product, it's better to stop the line and apply the treatment to recover the problem. Okay, so the principle of the maintenance is the same, but what is the important point is a bit different from the characteristics of the plant or the machines. So then if you understand what is different, then you can talk with each other. That is a very important approach, I think. So now I cannot cover everything, so I just picked up example of O&M optimization program as one of the type of the maintenance approaches. So this is a case of semiconductor manufacturing, and this case is a bit old one, but anyhow, so the concept is not changed even though even now, and so what we think is semiconductor manufacturing facility that is a dry etching equipment. So this equipment should be you should maintain the vacuum condition, but if you continue to operate, then the inside the chamber is there could be a particle inside the chamber. The production process generates the particle, and the particle could make a defect of the product, in this case wafer. So as I told you, that the particle generated by the process adhere to the wafer and cause yield reduction. And the particle contamination on the yield, effect of the particle contamination on the yield depends on the product characteristics. So the ruling distance is too small, then the particle affect the yield of the product quite sharply. But if the rule of the distance, you know that semiconductor rule, then the effect is a bit less than in the case of the very small rule. So the product which are more sensitive to the particle contamination should be processed first during the clean condition. And so this is the way to reduce the total number of defective product. But at the same time, so you have a delivery time. So you need to keep the delivery time. So just making the sensitive one first, that cannot be done in some cases. So we should determine the dispatching sequence considering both the due date and the maintenance timing to keep the yield above the threshold. So how you can make a schedule considering the operational requirement as well as the maintenance requirement. That is the issue. So as I told you that product one is more sensitive to the particle contamination. So here you need to apply the maintenance. And product 2 is less sensitive, and the timing of the maintenance can be longer than in the case of the product 1. So this means that first you produce a product 1 and then product 2. That in this case the number of the defective products is 630. But if the first produce a product 2 and then product 1, then the defective product increases. So the sequence is quite important. And we use the model of the increased particle, model of yield reduction. And then we have objective function that is A is ideal turnover, and dy is a loss of defectives, dd is a penalty of delay in delivery. So we want to maximize f, and the way of the optimization, we use the so-called genetic algorithm. Do you know something about the GA? Genetic algorithm. It's a mitigation of the mimic of the gene, the behavior of the genes. So genetic algorithm we call GA, which mimics the genetic mechanism, how the crossover happens in the progress of the human being or the natural. So I'm sorry, I don't have enough material to explain what is genetic algorithm, but if you Google it, then there is a lot of information about that. And this is quite a common approach right in these days to solve the problem of the combinational problem. So it is also applied many times in the production scheduling problem. Okay, so anyhow, so we make this kind of the optimization calculation, and then this is one of the example of the result. So in this case, here product 1 is a high sensitivity and high price. Therefore, at the first stage, product 1 is produced. Product 2 medium sensitivity, product 3 low sensitivity. So, but the first in this timing, the product 1 has a priority, but at the same time, so when the time goes, you need to think about due time, delivery time. So then there are they start to produce this product 3. So anyhow, this kind of the problem is an example of the so-called operational maintenance optimization. And again, so this kind of the maintenance strategy should be assessed because as I told you, there are many kind of the component, and for each component you need to select the maintenance strategy and combine it to apply this kind of the maintenance activities. So again, we need to evaluate. We use the kind of simulation for evaluation of this type of the maintenance planning. And there are two ways One is using the distribution function. So you know that Monte Carlo, there is a way of the simulation called the Monte Carlo method. Monte Carlo method means that this is just a simple explanation of the Monte Carlo method. If you have, you need first you need to identify the area and put the dot randomly in this box. And what you want to do is you want to know this circle area, to know the circle area. And if you count the red dot inside the circle, a dot are produced randomly. The position of the dot is produced randomly. So red dot is 11, and the blue and red one is 14. So in this case, inside the circle dots, the number of dots inside the circle divided by total, multiplied by 4, that makes pi. And if you calculate this number, then you can get 3.14, etc. And the correct one is, as you know, 3.1415 and so on. So even though the total number of the dot is 14, you can get a rather good number of the pi. So if you increase the number of the dot generated, a randomly generated dot, then the accuracy of the estimation become better. So using this kind of this technique, if you know the distribution of the failure occurrence, then you can simulate the maintenance. For example, this is the case of the breakdown maintenance. By using this distribution with a random number, you can say that this timing the failure will occur, and then if the failure occurs, then maybe part will be replaced or repaired, and then distribution will shift it by this time, and then next time. So continuing this type of the calculation, then you can say how many failure will occur and how many treatment have to be done during the certain period of time. And if the time-based maintenance, first you generate the timing of the failure, and if the timing of the failure is before the maintenance timing, then you need to make a breakdown maintenance. But if the generated timing of the failure is after the maintenance, so then you can prevent this failure. And then if you make a treatment, you can generate another, the next failure distribution, and so on. And in case of the condition-based maintenance, you can predict the deterioration for the I just simplified just straight line. But that can be a certain curve. But anyhow, if you can predict the functional limit, then this is a detectable limit. Of course, there is some certain kind of the uncertainty, so you need to apply this kind of the distribution function. But anyhow, if you can detect first, you need to identify the functional limit, and then you can identify the timing of the detect of the symptom, then applying some kind of the treatment, and then you should revise the deterioration curve and so on. So this is a way of the simulation for condition-based maintenance. And also there's another approach. What I explained was the statistical approach, but if you know quite well about the mechanisms, then you can simulate the failure or the deterioration using the mechanical properties. So this is the example of the simulation of the robot. Usually the failure will occur in the robot of the joint. So, but if you know the program of the robot, then you know the behavior of the motion of the robot. And from the motion of the robot, you can calculate the force and moment applied on the joint. And then if you know the joint mechanism, maybe you have gears in the joint, then how much stress is applied to the surface of the gear, you can calculate the contact pressure or sliding length. From that, you can, of course, you need a certain kind of the model, but you can calculate the how much wear will occur in a gear. Then that wear causes the positioning error. And so this is the estimated amount of the lost motion. Lost motion is, there is, if you have a backlash in the gear, if you move this way and then you want to return it, there is a certain range that how can I say, the motion doesn't work because of the backlash. So that is called lost motion. And we measure this kind of the lost motion in the actual robot in the plant, and also we calculated the lost motion using the model. And the absolute value differs each other quite significantly, but the tendency or the overall tendency is quite agreed with each other. So by using this kind of system, for example, you can adjust, or you can find the way of the motion which leads to the less wear. So again, we apply the genetic algorithm for the optimization, and this number is a joint number. One is this motion, and two is this motion, and so on. So, and the most in joint 2, it has a biggest loss wear, and this is the original motion. And if you optimize the motion, then you can reduce the wear, amount of wear. Because so if you stretch your arm, then you need to rotate your arm. This rotation is necessary for changing the position. But the torque on this joint is larger. If you shorten your arm, you need more rotation for changing the position, but less stress only on the arm. So considering this kind of the differences, you can adjust, or you can optimize the operation or the movement of the robot, and that makes robot more, how can I say, reliable in terms of the wear. Okay. So what I talked today was that the maintenance is one of the most important means of life cycle management from the aspect of circular economy. A framework for life cycle maintenance management is proposed, in which it is proactive as well as adaptive at the same time. Procedure of maintenance strategy planning consists of technological evaluation, which select the technologically feasible maintenance strategy. Then managerial evaluation, in which you prioritize the maintenance or prioritize the failure of the components. And maintenance management approaches are categorized in terms of effect categories and maintenance cost patterns to what is different in each area and what is common in each area. You can know by this kind of the categorization. And as an example of maintenance management, O&M, operation maintenance optimization, is presented by taking the case of semiconductor manufacturing. For evaluating appropriateness of the maintenance management, two types of life cycle maintenance simulations are introduced. Okay, thank you very much. Any question?
I just want to add one thing, that the simulation is, Monte Carlo simulation is one kind of approach, but one more approach which is very prominent is, first of all, we study the external pattern, and because all the external factor, whether the power default or no proper supply of power, or maybe there might be a defect in proper fuel, which is affecting the functionality of the machine. So if we study all the, or maybe because of no proper temperature, the machine, maybe the machine needs a vacuum space. So first of all, we should consider the external factors which are affecting the functionality of the machine, which is directly connected to the internal functioning. So this approach of top to bottom approach, maintenance can also
this type of approach is categorized. The second example, you need mechanisms of the deterioration of failures, or in that model you can consider the different factors outside, external factors, internal factors, and so on. So you need you need some certain kind of the model to describe the behavior of the component or the systems. So then you can simulate what will happen in this operating condition, or in this environmental condition, and so on. So, but sometimes you don't know this kind of the mechanism, but you have a long experience and you have many data of the failures. So then you can, using this kind of data, you can estimate the distribution of the failure occurrence. Then in that case, so you can take a first approach. So it depends on how much knowledge do you have about the machine, about the deterioration, about the failure. So you need to decide, or you need to recognize what is the level of your knowledge level. So then you can you can select the appropriate approach. That is a very important point. Thank you.
Thank you for that the topic. So I want to like to comment how the top management should encourage the people to implement this.
Pardon?
How the top management should encourage the people to implement these activities, because top management only focus on the number of products and volumes. Currently, people are engaging only in the breakdown maintenance. People are far from doing preventive or predictive maintenance. What is your comment on this?
Yeah, that's a good question. So, but I think that yeah, you're right. So sometimes the top management ignores the importance of the maintenance. So they are looking at just the production, and you have to keep your schedule and so on. So, but nowadays, you know that circular economy is a big topic even for the top management, and then gradually I hope that they recognize the importance of the life cycle management. So, and that means that the importance of the life cycle maintenance. So I don't know the right answer for that, but anyhow, so I hope that the trend of the circular economy pushes, or the people pushes the people to recognize the importance of the maintenance. So they start to discuss about the business model. So as I told you that just selling the product from the providing the functionality. So in that case, so maintenance is quite, you can recognize, you may recognize that the maintenance is a profitable approach. So some company want to change their business model from just selling the product to the life cycle business model to support the whole life cycle, to providing service of the maintenance or the way of the using the product and so on. So,
Any questions? We have a break and we will